Hi, this is Rafiqul Islam. I'm a master's student in Texas State University. In this video, I'm going to show you a basic heat transfer simulation in COMSOL Multiphysics software. I have divided this video into three sections. One, defining the goal and the problem. And two, defining geometry and the boundary condition. And finally, three is running the simulation to solve the problem and analyzing the result. Now starting with the problem and goal. This is a 40 feet shipping container which is made with sandwich material of aluminum and polyurethane with a 3-layer. Both side has aluminum and in the middle there is polyurethane. And there is a water reservoir inside the container with water in it. So our goal is to see how the outside temperature, ambient temperature, affects the inside temperature of the container, inside air temperature, and how this air temperature affects the water inside the reservoir. So this is our goal, to determine the effect of temperature from outside to inside and then the water. Now building the geometry in COMSOL. First we will start the project with wizard option right here. Click on it. As our model is 3D, so we will select 3D here among all these options. Now we need to select the physics. In this case, we will select heat transfer in fluid, as in our case heat is transferred through air and water. So we will select fluid and click add. Then study. Now we need to select time dependent option, because we want to see how the air and water temperature changes over 24-hour time. So we'll select time independent and click done. This is our COMSOL window. Here first we will need to build our geometry. So to start with geometry, we can import from other software, or we can create our own geometry here. As our model is simple, so I will start with creating my geometry right here, starting with geometry tab on the top and a block. I'll set the diameter of the inside of the container, which is 40 feet by depth 6 feet and height is 8 feet. Click build selected, and now I will select the transparency option here to have a better look. So we have built our air domain as a block here. Now we need to build our water domain. To do that, I will click block again, which is block 2. I'll put the dimension of 36 inches by 18 inches with height of 15 inches, and I will position it around in the middle of the container, which should be 20 feet in x-axis and about 3 feet in y-axis. Then I will hit build selected. Now we're done with building our air and water domain. We did build the geometry of the water and air, but we need to define that this is air and this is water. So to do that, I have to go to the material section here, right click on it, add material from library. We will select build-in and double click on air. By doing this, the COMSOL software will apply air to all of the domain here. So we need to override the inside domain. To do that, we have to select water liquid here and select the inside domain. One thing to notice that to select the inside of a geometry, to select another geometry inside of other geometry, I am just scrolling the mouse a little bit. This way it will shift the selection to the other domain or other part of the geometry. So I'm going to select this one, and in this part I need to select specific gas constant. I went over to the internet and found this value to be exactly this value, which is 461.52. Then we're done with defining the water and air. Now we need to make the outside material of the air and the water, which is in this case the wall of the container and the water reservoir. To do that, we need to make a layered material. So we need to go to the material section, layered material. I will make this first. I will make this 2 mm for with the medium of mesh size 5, and the material is aluminum here. Now our layered material is made. Now we need to add this layered material to our domain to make the thermal insulation or the wall. To do that, I'll go to the layered material again, in component section, material, right click on it and layers, and layered material link. I will link the layered material I just made a moment ago. I link those layered material to these domains. So let's click layered material link, and now I will select all the for layered material 1 here, the sandwich material. As you can see here, we made with 3 layers of 2 material. It is selected here. Now I need to select the which faces the layered material should apply. So starting with this face, this one, this one, this one, actually all the faces of the same material. Okay, we are done with applying the layered material 1 with the container. Now it is totally insulated with the sandwich wall material. Now we need to define layered material or the water reservoir for this water domain. To do that, let's go to material again. Here, layered material link. This time I will select this face, this face, this face, this, and this. Okay, and I have to select layered material 2 in this case. Done. We have successfully selected the material of the wall and the water reservoir. Now I have to define outside ambient condition, the ambient temperature and the wind condition. To do that, I will go to the component section and the definition, right click on the definition, go to shared properties and ambient properties. From here we will select meteorological data, this option, and for the location I will select the San Marcos. Let's find it in the list, United States. It's loading all the weather stations of USA. I will look for San Marcos. Let's go to S. There, the San Marcos. Double click on it, and we need to define the day of the weather data. I will select 29th of March 2021, and local time should be 16, as we actually started our experiment at 4 p.m. on 29th of March. So there's our ambient condition. We have successfully made our ambient condition. This is easy. All the work, all the temperature and wind direction, wind condition, everything will be connected with the meteorological data, and the COMSOL software will apply to it. Now we need to add a heat flux in our system to make a heat transfer from the outside ambient condition, ambient temperature, to the inside air through the wall material. To do that, I will go to boundary and click on heat flux. Right here, first I need to select which wall should be considered. I will select all the long walls for now, and I will add another heat flux for the short walls. So next stop, I will select material type from material that we already defined for this material, and for the heat flux I will choose convective heat transfer, as the air comes from the outside to the wall with convection. And for the heat transfer coefficient, I will select external force convection, as air has a big role here. So this is external force convection. For length, I will select the length of the wall, which is 40 feet in this case, and fluid is air, looks good, and absolute pressure I'll choose ambient condition that we already set up for this specific location, and also the external temperature I will select the ambient condition as well. And for the fluid velocity as well, the ambient condition. All the ambient condition is set up with convective heat transfer. This is the equation COMSOL will solve for us to make this heat flux from outside to inside. Okay, let's add another heat flux for the shorter walls. Boundary, heat flux. This time I will select these two short wall,
and convective like before. Material is from material. Heat transfer coefficient, external force convection. And length is 6 feet in this case. Velocity from the weather data. Fluid is air. Pressure is also from weather, or 1 atmosphere is also fine. And finally the external temperature, it is from the weather data. Okay, looks good. We have set up all the walls with heat flux. Now last thing, I need to add a thin layer to make a connection with the layered material with the boundary condition. So let's do it. To do that, I need to go to boundaries again and click on thin layer. And first I will select all the outside walls for my first thin layer. Okay, and I will add another thin layer with the wall of the water reservoir. Okay, we have successfully added thin layers for the water reservoir and also the outside wall condition. And we need to define one more properties here in the polyurethane section in the material. We need to put a value for heat capacity and constant pressure of polyurethane, which is I found about 400. I found this online. This is it. We're done. There is no more cross. And other one more thing I forgot to mention is in layered material link, I need to select downside on boundary, because if we see the layer, this is, if we select mid plane, it's on the middle. So I want to be the first layer is touching on the air domain. So to do that, if we select downside on boundary, the aluminum layer will be in contact with the inside air, and also the outside layer will be in touch with the outside ambient condition. And we will do same for the water reservoir, downside on boundary. That's it. We have successfully set up all the conditions. Now it's time to add mesh, to define the mesh. To do that, let's click on mesh, and for this case I will select extra fine. Finer the better. Let's choose extra fine for now. And if we click build all, there the mesh has been set up, and all the conditions are also set up as well. Now it's time to go to the study section. In study, this is our final part. In study, we will define some parameter and start our simulation. First, we'll select time dependent in study, and here I will select the time step. This is an important factor. Here I will choose start with 0 with the time step of 0.5 hour, which is half an hour, and it will run for 24 hours. Okay, looks good. I will click replace. Then when I click the compute, the software will start the simulation, and it's gonna take a while. So I'm gonna click compute now and pause the video for now, and I'll come back when the when you get the result. Welcome back. Our simulation is done. Now I will go through the result section. There are some few things I need to go through. First of all, there are some options here. I will start with data set. I have already added some data set. To add these data sets, we have to right click on the data set and click on solution. Then we can click plot, and when we click plot, we can right click on this data set and click selection. Here we can select the domain we want to select. In this case, I will select the air for now, and okay, that's the solution. And after adding this data set, let's delete this for now because I already added the data sets with selection here with the air, and with selection with only water section. And this data set is the whole selection, whole geometry. After adding the data sets, we will have to add some plot group, 3D plot group. Here is the 3D plot group. To add 3D plot group, we have to go to the result section and click on 3D plot group. After we click 3D plot group, we will have this dialog box. Here we can see the data set that we selected, that we created earlier. The first data set is for the air domain, second one is for water domain, and third one is for whole geometry. Let's keep it the air domain for now. Looks good. After creating the 3D plot group, we need to add surface plot. To do that, similarly, clicking on 3D plot group or right click on 3D plot group, we can click surface. After we click surface, we will have this dialog box. We can choose the data set like before, solution 1 for now, and time I will select 24 hour, and the unit is degree Fahrenheit. If everything looks good, we can click plot, and after clicking plot, we will have this temperature gradient after 24 hour result. And after plotting 3D plot group, we can also plot another 3D plot group and add volume. This is the whole volume of air and water after 24 hour. And one interesting thing is 1D plot group. In here we can see the graph, and that how the temperature changes with the time. The green line here represents the air temperature, and the blue line here represents the water temperature over 24-hour time. And there are some options to play with. We can add labels and some other parameters. In surface plot, we can also change the range of the color. I have selected minimum 65 and maximum 90 degrees, so we can have a better look. After plotting all these plot groups, we can have animation as well. To add animation, similarly, we'll have to go to the result and click on animation and player. After clicking the player, we will have this dialog box. We can select this dialog box. We can select the number of frames and display each frame for 0.5 seconds. That way it will be a little faster. If we can play this animation, we can see the change in temperature. See the temperature of the air is changing over time. This time is showing here 19 hour, 20 hour, there 24 hours, and after 24 hours it looks like something like this. That's the result. And in table section, if I go back to table section. We can add the table similarly in similar fashion from here. We'll have this table data here. We can see that table graph by clicking this button, and also we can export. There is an export option. We can select the export file format, CSV or Excel file, so that we can use it at a later time to analyze later. So that's the result section, and that's ends my video. Thank you.